Okay, we're back. So in the last session, in the last part, or the second part of the last session, just pointed out this little oversight here. And if it's happening here, then it's probably also, well, I don't know, are there any other message boxes? Let's see, message box. Yeah, there's a message box here. We want to do a return after that one. Okay, those are the only two. Okay, now what's next? Okay, the next thing is minor, and that's just that there need to be upper and lowercase versions of letters. Now, one thing, just as a comment, is that this one, in this function, the variable name alphabet was chosen, and in this function, the name letters was chosen. And that's inconsistent. And you want to be consistent. Should be more consistent. But the real problem is this code here. The fact that this is here, period, is just wrong. This is here to take advantage of the index function to get the offset of the letter in this string. And it actually gets a zero-based offset, such that A comes out as a 0 and Z comes out as a 26. No, I'm sorry. Z comes out as 25. So this comes up from 0 to 25. And we're trying to get an index. But this is a poor way of doing it. The best way to convert this letter to an integer is to use the Python ORD method for the ordinal value. So instead of calling alphabet.index, it's better to go old index equal ORD of the letter, because that will convert it directly to an integer. Of course, you have to subtract. Since this is lowercase, you have to subtract the ordinal value of the lowercase letter. So now what will happen is, if letter is a small a, it'll get a numeric value for the small a, subtract that from that, the numeric value of a small a, and this old index will now be 0. The problem with this is that we're actually going to have to step through each element in order to find the first occurrence of the letter, because technically I could have another A in here. So what index does is it finds the first occurrence of the letter in the string. It doesn't do this, it doesn't sort this first or do anything. It's just going to start marching through in a loop one at a time until it finds the A in the string, and then it's going to return the index, which means that it's going to find an A much sooner than it finds a Z. So the average time for this function to run is going to be 1/2. Well, actually, it would depend on the frequency of letters used in the message, but it's not going to be instantaneous. It's not going to be a one-step operation. Whereas this ORD function just does it directly. Now, if these were uppercase letters, then instead of subtracting a small a to get the index, you would subtract a large A. But once you've done that, the effect is the same. You're going to have an integer value representing the letter, and the range would be from 0 to 25 without having to search through a string each and every time. Because every time you go through this loop and you call the index function, it's gonna do a search over and over and over again. So this is not the way to do this. This is the correct way to do this. And if you wanted to, you could just say if letter dot is upper then subtract the capital A, else subtract a lowercase a. Now, okay, we get to this. Okay. Okay, else's are not a good thing. And then else's that are tailing along at the end of something are a very bad thing. Now this else and this else are a little different because the else is still is very closely situated with the if statement. So this is very clear. I'm doing this, I'm going to execute this statement, or I'm going to execute this statement. This else is so far away from the if, and if this was even more complicated, it could be pages down. So it's better to do the simpler cases first. So this code should be up here. This else should be here. And if not letter in alphabet, then handle this. And actually, in this particular case, we have an if and an else that is nearly symmetrical in terms of the amount of code that would be executed. This is a perfectly fine if and else. This one is not so symmetrical because in this case, once we're finished with this, we're going to process the index the same way regardless. We don't care if it's upper or lowercase. We're going to process the index and do what we have to do and come up with a new value that's still going to be problematic because slightly problematic because if we convert everything to 0 to 25, we're going to lose the fact that it was uppercase here. So down here, actually it's still not a problem because we still know if letter is uppercase, so we can do the test again. We're going to go to the alphabet, which is what this is, and we're going to pull out a letter, but what we could say is if letter dot is upper, let's say this is uppercase letters, else index into lowercase letters. And then instead of calling this alphabet right here, uppercase, lowercase. Now, it may seem strange that I'm saying, okay, you can use upper and lowercase for this purpose, but not use it for indexing. So this this shouldn't be here. And in this particular case, we're directly accessing an element. We're not searching through to find it. We're just going to this position, getting what we want, which is a good use of this string, but this is a bad use of the string. Now, I wonder, will this work? So let's stop it, run it. Now, okay, I gotta put a colon here. Guess we need to learn how to program. So if letter, line 193, letter, okay. So save it, run it again. Else, gotta put a colon there too. Gotta put a colon here too then. Oops, I'll do that. Okay, so run it. It runs. Position it. This is a test. And then we're gonna just leave the defaults. The letter is not an alphabet. 187, which is right here. Okay. Okay, let's go back. If not letter in alphabet. Okay. I don't like just changing letters. I don't know the consequences of using is alpha. So we'll just create another string with all the letters and try it that way. So if letter is not in letters, where letters is all of these letters, upper and lowercase. All right, so here we go. This is a test. This is all fine. Cipher the message, still crashes. Letters is not defined at all because it's all letters. I know there's a strip in this code, so I'm going to see how that works. Put some blank lines. Okay, so let's do that one. It worked fine. Let's give it an offset of 1. Notice that I did get the uppercase T coming out there. Let's just offset it by 1. I have an uppercase U here, which is different from the lowercase u here. So now the upper and lowercase stuff is handled. I don't need a message copy. Okay, I take that back. Maybe the stuff wasn't handled. So let's deal with message copy, because we got message copy, message copy. So what we wanted to do is not have this second loop. Offset it with the 1. decrypt it. Oh, it still came out lowercase. Whoa. That's because this is using the copy instead of the original. So if we take off the copy, and I'm not even going to move the window because the window doesn't want to do what I want it to do. Window does what it wants to do. 1. And so now I got the uppercase U. So then if I take this up here, cut it out, let's reset, paste it in, Visioneer, decode of 1, and then it comes out as this is a test. So that properly handles that. So that's the way to go about doing that. Get rid of the loop, get rid of the copy, although now I did say the stripping was okay. No, because I didn't save it. So how did it get stripped? I don't know how I got stripped. That's not the point of this session. So anyway, talked about so much. I forgot what I talked about. Oh, indexing. Indexing is a search. Searches are evil. Take a long time. Directly converting, just do the math. There's a numeric value for every letter, which you can get, and then you can do a subtraction operation much faster than doing a search. Okay, that's that one.